I am Yuto Ueda from Keio University in Japan. I will be presenting Tactile presentation of Orchestral Conductor's motion trajectory. First, as the background, the concept of diversity and inclusion has been gaining traction in recent years. As a result, it becomes important to ensure that cultural and artistic activities like musical performances are inclusive and diverse. However, visually impaired individuals may still find it challenging. For example, they may feel hard to perceive conducting movements, leading to difficulties in musical ensemble. Related work has considered tactile methods to share conducting information with visually impaired individuals. These methods typically involve the use of vibrating devices placed on the wrist or arm to convey beat information extracted from conducting movements. While methods using both tactile and auditory feedback have been proposed, they often have the problem of interfering with the perception of surrounding musical sounds. So tactile methods are more widely accepted. However, one challenge with these existing methods is to present the trajectory of conducting movements. Performers usually predict the timing of the next beat by observing the conductor's trajectory. And information, such as the scale of conducting movements, is crucial for conveying musical expression. But existing methods struggle to intuitively present this information to the users. In this study, we propose a method to present conducting trajectories using tactile apparent movement for visually impaired musicians. The system senses conducting movements using motion capture and presents the obtained 2D trajectories on the user's back using 16 vibrators arranged in a plane. Now let me explain the principle of tactile apparent movement. When two stimuli are presented sequentially at distinct locations, it feels as if the stimulus is moving continuously from the first to the second point. This phenomenon, where the movement of discrete stimuli is perceived as continuous movement, is called tactile apparent movement. In this study, we achieve this by controlling the vibrators. First, we normalize the x and y coordinates of the conducting movements to a range from 0 to 1. Then, as shown in the lower right diagram, we divide the xy plane into a 4x4 grid of 16 areas and activate the corresponding vibrator to replicate the conducting trajectory as tactile apparent movement. Now let me discuss the experiments we conducted. In this experiments, to quantitatively evaluate the effectiveness of our proposed method, we compared the response times between our method and a previous approach, known as point presentation. Point presentation here refers to the method used in previous studies, where a single vibrator synchronized with the beat was used. Response time, as shown in the diagram below, is the time discrepancy between the correct beat timing and the timing predicted by the user through tactile sharing of conducting. A smaller difference indicates a shorter response time, which is considered more desirable. As a recording method, participants were instructed to press the space key on a keyboard when they feel the beat. In this experiment, we evaluated the participants' comprehension of tempo changes and their perception of the start timing of musical performances. We evaluated response times for tempo changes on accelerando and retardando, where accelerando represents gradually speeding up and retardando represents gradually slowing down. In each of these conditions, we changed the beats per minute over 10 seconds and measured the response times. Regarding the methods of tempo changes, in actual performances, the transition from the original tempo to the target tempo can vary, ranging from linear to sudden changes. Therefore, to evaluate adaptability to various tempo transitions, we set 3 types of transitions. The first is the simplest method, where the tempo transitions linearly. The second is an exponential transition. It was adopted based on interviews from previous studies that revealed tempo often transitions exponentially in actual performances. The third is the mean of linear and exponential changes. For each condition, we set 3 types of BPMs, 60, 80, and 100, conducting 2 sets for each. Regarding the results, for accelerando, a significant difference in response times was found for linear and exponential transitions at some BPMs, with trajectory presentation resulting in significantly shorter times than point presentation. For retardando, significant differences were observed in all types of transitions, favoring trajectory presentation. We also conducted experiments to evaluate the perception of the starting time. In this experiment, we focused on measuring the response time for the starting beat. The measurement follows a preparatory motion. The preparatory motion is a gesture by the conductor to signal the start of the performance. We conducted this measurement with either 1 or 2 preparatory beats. BPMs were randomly ranging from 60 to 100, and each condition was tested in 30 sets. The results showed that for 1 preparatory beat, trajectory presentation significantly reduced response times. In the discussion regarding tempo changes, trajectory presentation allows for expressing movement transitions leading to the beat. So, trajectory presentation may make it easier to predict the beat even with tempo changes. For start timing of the performance, point presentation requires predicting tempo through vibration intervals. This method typically needs at least 2 beats of vibration to accurately determine the tempo. In contrast, trajectory presentation continuously shows the conducting trajectory between beats. So this helps timely tempo prediction even with just 1 preparatory beat. We have conducted 3 workshops with visually impaired musicians and co-designed the device. To enhance the sensation of vibration, we developed a wearable device with a high back fit. We had a visually impaired horn player wear the developed device and perform in an actual ensemble. Subsequently, we conducted semi-structured interviews to qualitatively evaluate the system. From the interviews, several strengths of this system were identified. These include the ability to understand the scale of the conducting gestures, thereby grasping instructions for volume changes. Another strength is identifying the number of beats the conductor is using. However, there are also weaknesses. One highlighted issue is the need for users newly to adapt to tactile information. Additionally, the inability of the system to present depth information by the conductor was noted. Regarding limitations in future work, a limitation is the requirement for an environment to conduct motion capture. As for future work, we plan to conduct workshops with performers that play different instruments to create a device independent of the played instrument. This is a summary. That's all for my presentation. Thank you for listening.